Hello everyone, how are you all? Welcome back to Igcse.science.notesz, and in this video we will be doing a revision on the AS organic chemistry. This is from Unit 1 in Excel, but I'm pretty sure it's going to be very useful for AQA as well, and maybe for what is it called? OCR. I'm sorry I said organic chemistry. As you see in the title, it's not organic chemistry. We're going to do everything but organic chemistry. So let's get started. Please upload. Open, dear sister. Okay, here we go. So, hello everyone. In this video, we'll be starting with the equations and reaction types. So, elements. Elements cannot be broken into simpler substances, and not every element identical cause isotope. However, all atoms in an element have the same number of protons, which is the atomic number. Atom, smallest particle of a chemical element having properties of the element. Molecules, two or more atoms bonded together. Compound, atoms of different element chemically combined. Ions, lost or gained electrons to have a charge. Anion if it has negative, cation if it has positive. Reactions, as you see, cation has the letter T like a positive sign. Anion has the letter N like a negative, so it's like negative, okay? So, reactions of acids. HCl is hydrochloric acid. HNO3 is nitric acid, H2SO4, sulfuric acid, H3PO4, phosphoric acid. With metals, metal plus acid is salt plus hydrogen. Metal oxides and insoluble metal hydrogens form metal oxide plus acid forms salt plus water. Metal hydroxide plus acid forms salt plus water. With alkalis, which is soluble metal OH, acid plus alkali is salt plus water. Metal carbonates, metal carbonate plus acid, salt plus water plus carbon dioxide. Metal hydrogen carbonates, salt plus water plus carbon dioxide. Okay, what about the displacement reactions? One element replaced by another element in a compound. Potassium, sodium, lithium, calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, and gold, I think? Silver, I'm not sure. Anyways, the precipitation reaction, solid forming used in chemical tests, carbon dioxide gas, adding lime water, CaOH2, and forms white precipitate of calcium carbonate, carbon O3. SO4 to negative ions, adding BaCl2 forms white precipitate of BaSO4. Halide ions laced adding AgNO3 and forming precipitates of silver halides. Yeah, Ag is silver. Energy and calculations, which is basically the 1C lesson. Anyways, relative atomic mass, weighted average Avogadro mass of an atom compared to 1/12 mass of a carbon-12 atom. Relative molecular mass, sum of AR of each atom in a molecule. Relative formula mass, sum of AR of each atom in a formula plus ions and molecules. Molar mass, mass of 1 mole of a substance. Avogadro's constant, 6.02 times 10 to the power of 23 number of particles in 1 mole of a substance. Number of particles, oh my god. Okay. Moles times Avogadro constant. Number of particles divide moles. Number of particles divide Avogadro's constant. Moles times molar mass. Mass divide moles. Mass divide molar mass. And it's like the triangle. Combustion reaction. 32 gram of methane burnt. How much oxygen formed? Write the equation. CH4 plus 2O2. 2H2O plus CO2. Calculation mole of known substance. N is equal M over MR. And here you have 2. Mole ratio, calculate the unknown mass, excess calculations, etc. This is not our thing. We're going to go directly into percentage yield. Actual yield over theoretical yield times 100. Mass of product over mass, MR of product over mass of reactant over MR of reactant. The atom economy, desired product MR times 100 over all products MR. Formula equation. Okay, The percentage yield, basically actual yield over theoretical yield times 100 is equal to the mass of product over mass of reactant, which is MR of product over MR of reactants. Also, atom economy, desired product MR times 100 over all products MR, right? So we have now the formula equation in gases. The empirical simplest whole number ratio of atoms present in a compound, molecular action number of atoms of each element present over the formula unit of an ionic compound. Empirical formula, experimental method can be found by removing the oxide form from copper oxide, known copper mass, placed and heated in a stream of hydrogen gas in a tube. H gas plus oxygen in CuO stream of and copper metal. Excess gas is burnt off, tubes cooled and weighed. Process repeated till a constant mass is obtained. Empirical formula minus calculating method using masses as you see over here, percentage as you see over here, combustion analysis as you see over here, ideal gas equation. PV is equal N times R times T. P is in Pascal pressure, V is in meter cubic, which is volume, is equal to N, which is in moles, R, which is 8.31 joules, mole, negative 1K, negative 1, so it's constant, and the T is in K. kPa is PA is times 10 to the power of 3, and as you see over the other unit conversion. Calculations involving gas volumes. Avogadro's law says that equal volume of gases at the same RTP have the same number of molecules. 100 centimeter square of H gas molecules equal 100 centimeter square of Cl gas molecules. 1L is 1 dm3 and which is equal to 1000 cm3. Molar volume is the volume 1 mole of gas occupies at RTP, which is 24 decimeter cubic or 24000 centimeter cubic. Volume in dm3 is basically moles times molar volume. Concentrations, mass, concentration times volume, moles, concentration times volume. Concentration in ppm used for pollutants in water, as you see over here. 1 gram in 1 million gram or 1 mg in 1 million mg. Concentration in ppm is equal to mass of solute times 1 million over mass of solvent. Has a concentration in ppm. Concentration in ppm is equal to volume of gas times 1 million over volume of air. Isotopes and mass spectrometer is the last thing we're going to do, inshallah. Relative isotopic mass is the mass of an atom of a particular isotope relative to 1 over 12 of the mass of C12. Relative atomic mass of isotopes, mass 1 times abundance 1 plus mass 2 times abundance 2 over 100. Mass spectrometer particles are turned into plus ions, oscillated and then deflected by an electric or magnetic field. Resulting ions path depend on mass to charge or m over z m over e ratio. A large m over z last deflected and small mz most deflected. Used for identifying isotopes, find MR, characterize new compounds. Vaporization, samples from atoms vaporize into gas. Ionization, gases atoms can get bombarded with E negative from an electron gun and are ionized, and sufficient energy is given to form +1 charge ions. Acceleration, ions are charge accelerated. Deflection, charge particles are deflected by electric magnetic field. Detection by electric or photographs. Phi method, the radius of the path depended on the m over z ratio value. Heavier isotopes have larger m over z values. They have a larger radius curve. Most ions are +1, so the AMT of separation depend on their mass. If an ion has +2 charge, deflected more, so m over z value is halved. Here again, the isotopes and mass spectrometer. The proton has a simple P, mass 1 and charge +1. Position is in the nucleus. Neutron is also in the nucleus but has 0 charge with mass 1 and simple N. Electron has E, mass 1 over 1840, charge is -1, and position is in the quantum shells. Atomic number is number of protons. Mass number is proton plus neutron. Isotopes are elements with same atomic number but different mass number. Same proton but different neutron. For example, C137 and C135. Relative atomic mass is the weighted mean average of an atom of an element compared to 1 over 12 mass of C12. Relative isotopic mass is the mass of an individual atom of particular isotope relative to 1 over 12 of the mass of C12. Relative atomic mass is mass times abundance over 100. Mass spectrometer particles are turned into plus ions, accelerated and deflected by an electric or magnetic field. Path of ions after deflection depend on m over z. Particles with large m over z are deflected at least and vice versa. Result produce a mass spectrum portraying different ions according to their m/z ratio. As you see over here, it's the same thing. Vaporization, ionization, acceleration, deflection, and detection. How it works is also written. Same thing, vaporized gas and X, electron gun, position ions, electric field, magnetic field, and the ion detector. Here, the mass spectrum, position of peaks, atomic mass, peak intensity, abundance, highest abundance scale 200%, and other values adjusted accordingly. Mass spectrum of diatomic molecules will be covered in the next video, inshallah. Have a nice day.